Okay, so we'll go ahead and get started with the rest of class. Let me move this over here. So what you just did, the written portion will take me a few days to get graded. I've got another exam for another class I'm grading. So I'm guessing I should have those returned either over the weekend or Monday or Tuesday of next week at the latest. Okay. All right. So we've been talking about this week summations and sequences. And some summations and sequences are particularly important in when we think about computer science. So let's take a look at some code here. This is some pseudocode. Since most of you are computer science majors, this is probably going to be a little review, but please hang in there with me. Computer science is not a requirement for registration in this class, and we do have some students who are not computer science majors, so they may not have had any computer science classes. So we're going to talk a little bit about pseudocode and what the code sets out to accomplish. So here I have some code, and the question is, what does this do? So suppose we have A1, A2, A3, and so forth up through AM as a one-dimensional array, and we want to think about an algorithm segment. So an array is just a storage space in the computer that has, for lack of a better word, individual slots. So there's a slot for A1, there's a slot for A2, there's a slot for A3, and it'll store information in each one of those locations. Okay, so what we're going to do is we're going to talk about what this code actually accomplishes. So as I'm reading through, I see sum equals 0. So sum is a variable, it's a location, and that location or variable is going to store the value of 0. Easy. And then it says for k equals 1 to m, so we're going to have this index like we've had in the summations. The index here is k, and k is going to count from 1 up to m. Pretty straightforward. So for k equals 1, so we'll start out with k equals 1, the sum is equal to sum plus ak. Well, k is 1, so this would be a1. So I would have basically 0, because I said sum was 0 to start with, 0 plus a1. So the value that's stored in that location called sum would be the value that is a1. Then we go on and we say, okay, so now k can equal 2 because we're allowing k to range from 1 to m, and it just increments. So when k equals 2, it's going to take the value that was in sum. Well, sum was updated when k was equal to 1, so sum now contains a1, and we're going to add to it a2 because we just said k was 2. So at this point, the value stored in sum is a1 plus a2. And we keep going. So we let k equal 3. And then sum is going to equal what was there before plus a3. And then we're going to let k equal 4. And sum's going to equal what was there before plus a4. So we've got, hopefully you're seeing the pattern here is a1 plus a2 plus a3 plus a4. And if we kept that loop going up to m, whatever m is, maybe m is 10, maybe it's 900, whatever m is, we're just going to keep adding the values that are stored in this array. So the value that's stored in sum is basically the summation of all of those entries in that one-dimensional array or storage structure. So basically what this is doing is, if you think about a spreadsheet, maybe it's adding up all the values in a column in a spreadsheet. It's the same kind of idea. So that's what a for loop does. So let me pause there. Any question? All right. So we can do alternative strategies. And so this is the code we just looked at. But it turns out that different programming languages address arrays differently. Some allow you to start indexing at 1, some start indexing at 0. So let's say we have the same problem, the same summation we want to do, but perhaps we're working in a language where indexing starts like A at 0 or something like that. So we need to shift our indexing is what I'm trying to say. So if you notice here, in the original for loop, K started from 1 to M. Now, in the new adjusted indexing, we're starting at 0. So what are we doing? We're subtracting 1 from the initial value of the index. So the terminating value of the index, we're not going to go all the way to M because there's only M entries. So we really want to go to M minus 1. We're just basically, instead of going to 1 to M, we're going to from 0 to M minus 1. We're just kind of shifting 1 in that range. Okay. So then the question then becomes, okay, so if we're incrementing I equals 0 to M minus 1, what does that sum equation in that for loop have to look like so that we're still adding A1, A2, A3, A4? Because if I say sum plus A sub I, there is no A0. And so A sub I would not work because that's not an actual location that would have some information there. So what we're going to have to do is we're going to have to adjust that so that I'm actually landing in an address or a position in that array where there is actually information stored. So, that should be A sub I plus 1, not K plus 1. Okay. So this is what you kind of practiced in the homework and in the lesson is just shifting the indexing. This is what this is doing. It's just doing it within some pseudocode for a program. So let me stop there. And again, that should be I plus 1, not A sub K plus 1. Are there any questions? Okay, perfect. So then let's take another look at for loops and think about that process. And we're going to compare it to another kind of loop called a while loop. So in this loop, we start by saying, okay, E is going to be 0, F is going to be 2. Then for J from 1 to 4, we're redefining F and we're redefining E. And then we're going to go to the next J. So those of you that have coding, you know about tracing. I'm going to use this table to help us trace. So initially, we define E and F as 2 and 0. And then we drop into our loop. So J equals 1. And then we say F is equal to F times J. Well, F times J is 2. So F is now 2. And E is E plus 1 over F. So I'm taking the previous value of E, that is 0, plus F. We just redefined F to be 2, so that's going to be 0 plus 1 over 2. So that first time through that loop, F is going to be replaced by 2, E is going to be replaced by 1/2. And then I drop down to the line that says next J. So then I want the next J. J was 1, so my next J is a 2. So J is now 2. I look, 2 is between 1 and 4, so we're still good. We keep going. So F then becomes F times our new J, which is 2 times 2, so that's 4. And then my E gets updated. It's going to be E plus 1 over F. So it's going to be that 1/2 plus the 1 over F, which was a 4. So we're going to get 4 for F and 3/4 for E. And then we go to next J. So I increment J again. J is now 3. And I look, I want J between 1 and 4. 3 is between 1 and 4. Now what I want you to do is take a minute. I'll give you about a minute. With this information, what is F and J going to be updated to be? I'm going to give you a minute. I want you to drop it in the chat, but not hit enter until I give you the go ahead. Okay, so what are my J is now 3. What is my new F and what is my new E? Okay, go ahead and hit enter. Okay, looks good. I see a 10/12. 10/12 is fine. F is 12. Very good. So yeah, once my J increments to 3 and I go back into my loop, my F will become 12. My E will either be 10/12 or 5/6. Either one is fine. Okay. All right. And so then we will go ahead and increment J one more time. J would be 4. 4 is still in that 1 to 4. 4 is the last option for J. And so as we go through that, F times J is going to give us 48. And then we'll have 5/6 or 10/12 plus 1 over 48. So that'll give us 41 over 48. And then next J would be 5. But if J is 5, then we're not in the 1 to 4 range. And so we would stop with the loop. Okay, any questions? Okay. Now, sometimes when we're working with summations and that kind of thing, we can use a for loop, but sometimes a while loop can be the preferred mechanism, and it can do much the same thing as a for loop. There are times where it is a better choice than a for loop, especially when you may not know what that last, in this case, that you want to end up with 4. You may want something that you're not exactly sure of, some kind of test to occur, and a while loop would allow you to do that. But we're just going to look at a simple example of converting something like this for loop into a while loop. Now, what do we need to do? So with the for loop, before we got into the loop, we knew that E had to start at 0, and we knew that F needed to start at 2. So we need to declare those. Okay, and then once we dropped into the for loop, we started with J equal to 1. So what we're going to do is, to start this while loop, I need to initialize those values. So I would set up something like this. E is equal to 0, F is equal to 2, and J is equal to 1. Now, the body of that loop isn't going to change a whole lot. A little bit, but not a whole lot. And basically what we want to do is we want to keep looping while J is less than or equal to 4, because we kept going through the for loop provided J was not bigger than 4. So we could say something like, we're going to do this loop while J is less than or equal to 4. And we initialize that J at 1. So when the computer reads that code, J is equal to 1, while J is less than or equal to 4, 1 certainly less than or equal to 4, it will drop into the loop and it will start doing what we want it to do. We still want F to be F times J. That's not going to change. We still want E to be E plus 1 over F. That's not going to change. But what does need to change is I need to be able to allow J to go from 1 to 4. J is currently 1, but I need to keep incrementing it. So I'm going to have an additional line that says J equals J plus 1. Or for those who code a lot, J plus plus. So that will allow us to keep incrementing J, and each time it goes through the loop, J will get a little bit bigger by 1. Now, the question is, we wanted this to happen while J is less than or equal to 4. So we need to tell the system, oh, by the way, when J is not less than or equal to 4, then you need to end the while loop. So then we end the while loop. Now this accomplishes the same thing as the for loop. In some cases, the while loop allows for a little bit more flexibility in implementing the code. So let me stop there. Are there any questions? I may have talked too fast. I don't know. Okay, all right. So what we're going to do is, let me set this here. And you over here. So what I want you to do is go into Canvas, and you should find there under Module 5 an in-class activity. And the password for that activity is the word Fibonacci. So let's make sure everybody can get in. All right. So everybody's in. I'm going to go ahead and create our breakout rooms. So when you go into the room, if you don't know everybody, I hope you've seen everybody at some point, but if you haven't, introduce yourselves. I'm going to pull you back in about, let me see the time, about 15, 16, 15 or so minutes just to see how things are going. If you happen to finish the entire thing before I pull the group back, go ahead and come back to the main room. But make sure that the entire group is done, not just you as an individual, because you should be collaborating, okay? Any questions? All right, I will go ahead and open the rooms. Okay, I pulled you back because I wanted to check in and see how things are going. Are there any questions that you want to ask as you're working through those questions? You can drop them in the chat or unmute yourself if you have questions. I'll just wait. David, go ahead.
All right, so for number 3, I'm having some problems with it. I first try to convert I into K,
Okay.
and had some. So everything kind of worked out, but when I was finished, it was all in a different like form than all the rest of the answers.
Oh, so
Like,
what you came up with looked different than the options you were provided.
yeah.
Okay. That's fair. You may have done it slightly differently. Let me look at the question.
Also, I'm kind of guessing that J would mean like something like I.
Well, yeah, you would have to decide. And so the use of J there is so that you're not necessarily tied to I or K. So it's a new symbol. It could be the same as I, or it could be the same as K, right?
Oh,
It's just a new index, a new dummy variable, so that it's not directly copied from either one of the summations. And so when you did your conversion, one starts at 3, the other one starts at 2, one ends at n, one ends at n plus 1. Okay, so the label of the index shouldn't matter. It does look like perhaps at least one of the options involves getting a common denominator.
okay.
and adding on additional terms that deal with the fact that both summations don't start at the same place and don't end at the same place.
All right.
So because they don't start and end at the same place, you're going to have a couple of extra terms that aren't actually in the summation itself, right?
Yeah.
Yeah. So take a look at those again. I suspect your answer is probably equivalent to one of those. Just take a look at, like, could I have gotten a common denominator? What were those terms that were extra? What did they look like?
Yeah.
That kind of thing. Okay. Does that help?
All right. Thank you.
Yeah, no
Yep.
problem. Any other questions?
For the question that asks about comparing the sequences,
Sure.
it has a text box for the answer. How do you want us to, like, what should the answer look like?
So you can, I mean, it's kind of free form. It's not going to be a formal proof, but I do want you to justify whatever you believe, right? Do they produce the same sequence or not? So it may be that you, similar to number 3, where you're like trying to work with similar indices, you may want to adjust one of the indexes for that sequence,
Okay.
that kind of thing. Does that
Okay.
make sense?
Yes, it does. Thank
Okay.
you.
All right. Any other questions? All right. I will open the rooms back up. When you're done, when your group is done, then you are free to leave, okay?